So now we're looking at scatter plots and association. This chapter is less precise and more of a general trend, looking at trends. So as we look at different graphs, we're used to seeing an exact change, an exact slope. These points are just a general guide, so we're going to have to look at them similarly but slightly differently. So on this very first graph, we notice that as the x value increases, so we're always looking at x from left to right. So as the x value increases, what is the y value doing? Well, the y values are also increasing because we are going up and right. These are both positive. This is a positive association. So we know it's a positive association if x is increasing and y is increasing. As we look at the next graph, we notice that as we move to the right, as x increases, the y values are coming down. They're decreasing. So our y values are coming down. This would be a negative trend or a negative association. So x is still increasing. The y is decreasing. And then there's a situation like this very last one, and the dots are just everywhere. This is called a no association. There's no obvious pattern. So right now we know that we can have a positive association, a negative association, or no association between a set of data. Now, we're used to straight lines, but as we look at these next two examples, we see that sometimes you could draw a general line through the middle. And the line that you drew was a straight line. So we would say that this data on the scatter plot is linear. Although previously linear to us has meant in a straight line, all of our dots have connected. This time is the trend linear. The trend is linear. What else do you notice about the trend? It is also positive. The x values and the y values are both increasing. On this next scatter plot, you see that if you were to draw a line through the dots, it's not a straight line. We would say this is nonlinear. But we would also say that since our x values are increasing and our y values are still increasing, this is still a positive trend or positive association. So whenever we're looking at is something linear or nonlinear, we're looking at the line that we drew, do the points, follow the line. If the points follow a straight line, we would say it's linear. If the points follow a curved line, we would call it nonlinear. For this next piece, if you have a general scatter plot, we could say that this was positive, but we notice that there's this little guy up here all by himself. We're going to call him an outlier. He's hanging out by himself all alone. There's also a thing that we call a cluster. So a cluster is a set of points that are sitting very closely together. So we're going to use all of these terms: positive, negative, no association, linear or nonlinear, outliers and clusters, and describe each of, let me reword that, I apologize. We're going to graph the data and look, what type of association does it have? Is it linear or nonlinear? Are there outliers? Are there clusters? But first we have to start by graphing our data. So A, construct a scatter plot of the weight of an alligator at various times after hatching. So all tables are set up as X and Y. We know our X-axis is talking about weeks. Our Y-axis is talking about weight in pounds. And we start plotting our points. So, zoom in. We have the point 0, 6, the point 9, 8.6. These are not exact, so we are estimating and doing it as precisely as we can. Scatter plots are not the most precise thing, so we're going with a general trend. The next is 18 and 10, 27 and 13.6, 34 and 15, 43 and 17.2, 49 and 19.8. So as we look at this data, we say, okay, does it seem to be an increasing trend, positive, negative, or no association? So I would say this does have a positive trend. Both the X and Y values are increasing. I feel like I could draw a straight line through them, and it would generally represent it correctly. So we would say this is linear. I don't see any tight groups. They all seem about the same distance apart, so we would say there are no clusters. And they all seem to be staying in the same general area, same line. There aren't any guys hanging out on the far away side, so we would say there are no outliers. All right, so the next example, example B. Describe the association, if any, among the observed data. So we're looking at those same four things. This group of, or this scatter plot appears to be, as the X values increase, the Y values decrease. This would be a negative trend, negative association. I feel like I could draw a general straight line through it. May not be perfect, but it's generally a straight line, so we would say this is linear. There doesn't seem to be any tight groups, so no clusters, and they all seem to be following the line, so no outliers. On example C, it says, describe the association, if any, among the observed data. And so we have a new scatter plot. As our X values increase, our Y values seem to increase. We would say this is a positive association. If I were to try to draw a line through the points and follow the points, that is not a straight line, so we would say this is nonlinear. There still appear to be no clusters and no outliers. They all seem to be following the line. They all seem to be reasonably spaced apart, similarly spaced apart. All right, so D, describe the association, if any, of the observed data. If an association exists, make a conjecture about the winning time in the 2020 Olympics. So we're making a reasonable estimation, a conjecture, based off of this scatter plot. So we see this scatter plot, the trend that it has. It appears that as our x values increase, our y values decrease. So we would say that this is a negative association. It generally appears to be linear. There don't appear to be any tight groups. And there don't seem to be any random dots not following the line. So we have described the association, and now we need to make a conjecture. So we see that each box seems to be counting by 4s, 2008 through 2012, 2016. I could continue my graph, and 2020 would be about here. So if I were to continue this trend line, we would want approximately an even number of dots above and below it. Maybe here. Oops. This point seems to be following generally with the trend line. Obviously, you would just need to be within a reasonable range. I'm going to say about 46 seconds, based on the rate at which it has been going down. The point that I added goes along with the trend line. If I were to have put a dot here, that would not be a reasonable estimate based on the scatter plot.